once we have this, okay, so there are two ways in which we can access all the HANA developments and all. So we have this web IDE, so we can directly log in from the website link, and there is a HANA Studio which we have seen. So for the Access Advanced Engine, we can directly log in from here. This is how it looks like on the screen. It's a data type HANA database. So we have all these things. Now here we need to understand a couple of things like row storage and column storage is what we need to understand. Row storage and column storage concept is extremely important for us. And whenever we are creating a database table in ABAP, we'll have a choice of either creating a table with row storage or column storage. So in the row storage, we'll be basically having the data stored like this. Now, let us understand with the example that we have on the screen. This, when we enter the data in the screens, the data comes and gets stored in the database table, and this data which we have in the database table will normally be a row storage data. Row storage, okay, data will be stored in a row storage. But then in the OLTP systems, OLTP systems it will be row based, and OLAP systems it's column based. Now what happens in column based is instead of storing the entire row, for example, let's say in a row in a table we have 150 fields. So you have already seen K1 Mara, these tables will have hundreds of fields. So let's say we have 150 fields and you have entered only 3 fields. Now for the all the other fields, other values, the it will be vacant, it will be empty. Even though it is empty, it will still occupy some space. So it is going to occupy some space for the row, the entire row. It's not just one field or two fields, it's the entire row. So what will happen, the entire row is occupied and the entire row is stored separately. But in the column storage, each value is stored only once. Each value, each column is stored as a columnar table. This is a column store table. So each one will be considered as a single table. So USA, France, UK, the countries are stored at one place. And all the persons are stored at one place and age are stored one place. In this, what happens? Data gets compressed. How the data gets compressed? If let's say a country is repeated 100 times, 100 times if it's repeated, 100 times it will be stored in the row storage, okay. But in the column storage, if you observe, France, okay, let's take USA is repeated twice, but it is stored only once in the columnar table, and that will be mapped back to the data. So if it map back to the data, then they both will be in sync. They both will be in sync. So the linking of the data will be taken care by the system. But here we have this one, okay. So we have row storage and column storage. So this is something we have logical data set, and this data is stored in row storage as a row, as a column storage it will be stored as a column, and row storage it will be occupying the row. I repeat once again what I said. In row storage, irrespective of how many values you are entering, if let's say we have in a table, one single row has 150 fields. For 150 fields, how much is the row? The entire row is occupied, with which there will be more memory space needs to be allocated for that. And not just that, even in the column also, if some data is repeated multiple number of times also, it is stored multiple number of times. So if you have the country 1 million times, 1 million times it will be stored. But whereas in case of the columnar store, it will be stored only once. This concept is extremely important for us to understand from the ABAP perspective. So if you see a table in the SAP HANA environment, let's say you are creating a table here. So every table that we create in HANA database, okay, let me create this. Okay. Now here we'll go to the technical settings. We have the technical settings. In the technical settings, if you see here, In the technical settings, if you see the database specific properties, so in the database specific properties, we need to decide whether it should be a row based store, column based store, or undefined. Undefined in the sense, we initially we are not going to give anything in the undefined. So we have this one. So row storage and column storage. Because of this reason, we need to understand very clearly whether it be row storage and column storage. If you know what is row storage and what is column storage and how it will be stored, later where we have to use row storage, where we have to use column storage is something which we'll understand later. I repeat, where to use it is something which we'll be discussing later. Right now what we are discussing is how the row storage and column storage tables actually work. Okay, so row storage and column storage work in this way. This is a technical concept for row storage and column storage. But if at all, if we have to use it, in what scenario we have to use row storage, in what scenario we have to use column storage is something which we'll discuss later. Okay, so real time examples of it is what we'll discuss later. But as of now we are discussing about the row storage, how it will work, and column storage, how it will work. Okay, if you have any doubt in this, let me know, I'll explain you once again. Row storage and column storage. So columnar storage allows us to uh, compress the data. So we have columnar storage, we'll have the data gets compressed. And in which scenarios we'll use column storage, which scenarios we'll use row storage is what we'll discuss later. But the way the data is getting stored is this, guys. The way the data is getting stored is we have this data being stored in the row wise and column wise. This is what we have.
Hello, sir.
Yes.
Sir, when in column storage, when data is repeated, it is not storing the value for the corresponding field.
Where you're saying in the row storage?
In column storage, sir, USA is repeated, so it's not storing that value.
USA is repeated, but in the columnar storage it will be stored only once.
When we go to that, it will store, sir? It will store the address of that or what?
Yes. Address of it. That I'll tell you. See, that is called surrogate ID. I'm not getting technicalities of it. So surrogate ID will be there. So surrogate ID is something, a unique ID will be created for this unique name. So for example, let's say for USA, it is 02. Then 02 will be stored for USA, and that surrogate ID is created by the system automatically. Okay, that surrogate ID's unique ID will be created by the system.
Okay, sir.
Any more doubts, guys? This is a very important concept. Okay, so you can also ping me if at all if you have any doubt. Okay, scenarios I will explain you guys. In what scenarios we'll do it, I'll explain you. So now we are coming to that surrogate ID. See, let's say if you have this Denmark, okay. For let's take we have the Denmark. Denmark is repeated twice. Okay, so this for 460 Denmark product COM, COM and 500. Now this Denmark data, we are repeating it. It's for Denmark data. We have this surrogate ID, that index. Okay, the index will be created. So index will be created, and the index is here. We have this index. So if you see this for Denmark, the index is something like 4. Okay, and now column not, it's a compressed column. So in the compressed column, it will be like for Belgium, the ID is 1, Denmark 2, France 3, and Italy 4, and Spain 5. So we have five unique values per country, and for 5 unique values, the 5 unique numbers indexes are been created. Okay. So now this 5 entries. Okay, totally 5 entries from the country table will have 5 entries. Now in the 5 entries, this first one, Belgium, is been added one, right? So one will be there for. Okay, guys, like here we have this data. Let's understand this carefully. Let's slowly understand. Okay, now Denmark is given number two, guys. Okay, this is a compressed column. So where was ordered 460. Okay, let's see 460. Now here, if you want to find the 460, what is the number of 460? 1, 2, 3, 4, 5. Okay, this is 5. Now the index will be 5. For this 5, what is linked here? Denmark. So this 2 is Denmark. Okay, now this 5 and 2 are been linked. Okay, 5 and 2 are been linked. Now 5 of this column, 5 of the first column is linked to 2 of the second column. You're getting it? So then 5 and 2 are been linked. Now if you see, this is an inverted index. Let's go to the inverted index later. Okay, first we are taking the example of the 460 fifth row. So the fifth row, these are the values that we have. Okay, is this okay? Is this clear?
Yes, sir.
Yes, that's important. So any see,
Oh,
this is a very important thing, guys. Like I'm explaining you in different ways so that at least in one way you will understand. Because everything might not be understood by everyone in a one go. Okay, that's normal. That's very normal. So I'm trying to explain you in different ways so that you can understand that. Now here we have this. Now let's see the 4. Okay, if you have 4, 4 is what? Italy. So this fourth one we are. So now we are getting the data based on the Italy. So for Italy, if you go for the inverted index for 4, all 248 are been linked. 248, what do we mean by 248? It means that for 4, that Italy, row number 2, row number 4, row number 8, whatever values are there, those are linked. Means row number 2, what we have? 457. For 457, it is Italy. For row number 4, what is it? 459. For that, it is Italy. And row number 8, 463, we have Italy. So 3 times we have Italy. So that's the reason 248 is been linked to 4. So this all linking process will be done internally, guys. This will not be shown to us. but we need to understand how it is happening in the backend. Okay, so if you want to find out where is 460, this is how you have to track. If you want to find how many orders were happened, orders happened in Italy, then this is how you will see. You can pick up everything from everywhere through indexes. With the help of indexes, we'll do that. Okay, guys. So I'll move on to the next screen. Now here, why HANA becomes so fast is if you have a huge amount of data in a particular table, and let's say you have chosen it as a columnar table, each column can be processed by each core. There can be multiple cores. Okay, so here we have core 1 is processing the first column, core 2 is processing second column, core 3 is processing third column, and core 4 is processing the fourth column. So it's like that. So parallel processing, this is called the parallel processing. One is the data compression. We are discussing about the data compression. The first thing is data compression. The second thing is data parallel processing. So first technique is called data compression, and how is this getting compressed in the columnar table is what we have understood now. And then the second concept is parallel processing. In parallel processing, each core will process one particular column. So we have the data temperatures. So data temperatures means, so how the data is getting distributed. If it's overloaded, then it's considered as hot. Okay, so if it's like less loaded, it is cool or warm. So something like that. Okay, so completely fully loaded tables are considered as hot. Okay, partially loaded are loaded are hot, a bit hot, and a bit cold as well. So bit warm. Okay, so these are like normally loaded tables are called it can be considered as warm. Okay, so there will be two categories here: hot tables and warm tables. Hot tables are those which are fully loaded. Okay, all the data is there, a lot of data is there. And table partially loaded by column A, so that is also we're considering it as a hot only. But here this column B, in which like we don't have that much of data, so like 2016 17 2016 17. So why this column A is stored is considered as hot is because each value is unique, nothing is getting repeated. Why this column B is considered as warm is because in this like 2015 16 only is getting repeated again and again. Okay, so here if you have a complete together, if we are considering it, it can be considered as partial loaded. Now this first scenario is when we are storing it in row storage it will be fully loaded and it is completely hot. When it is stored in column storage, it will be uh, warm. So these are the various scenarios in which we are considering hot and warm persistent. In short, you can just understand, guys, if a table is fully loaded, it is considered as hot. And if it is normally loaded and equally, I mean like it will have repeated number of repeated values are there, then it can be considered as warm. Now we have hot data and warm data all in one database. So we have hot data and we have warm data. So hot store, we have primary images image in memory. So we have the image memory is what we are storing here, hot store. And warm store, we have cache memory. It is stored in cache memory and processor. We have durability here and primary image on the disk. So in the HANA database, we have multi-store tables. We have partition 1, partition 2, partition 3. In memory store, column store, and we have extended tables. So we have partition 1, partition 2, partition 3. So these are multi-store tables. Okay, multi-store tables, in-memory store column tables, and extended store dynamic tiering. So I'll be explaining you this partitioning of the tables across two tiers, memory and extended storage. Okay, so we have multi-store tables. So we do the partitions in a table and store them in multi-stores. So there will be different types of data. One is the active data and another is active read enabled data. So we have read enabled data and write enabled data. So for read enabled data, if let's say you are frequently writing something, if you have to update regularly on a regular basis, if you have to update the data in the database tables, then row storage is better. But if you are accessing it regularly, if you don't update it daily, but you access it daily, if you access it daily, then it's column storage. So this is what we have, the difference between the row storage. So we'll keep on understanding, guys, when to use row storage, when to use column storage. These things we'll keep on we'll keep on exploring them. We have offload in read intent start to secondary HANA database. So make effective use of redundant secondary recovery server. So we have write operations, delta and main. So we have write operations. So this is a main memory. In the main memory, we have delta merge. What is delta? Delta is only the changes will be updated. Only the changes will be uploaded. For example, if you have a table of 100 records and if you are updating the data from some another table in which we have 110 records, let's say the 100 records is same, only if you are trying to upload in delta mode, only the changed values or new values will be updated from the table A to table B. That is what. Now we have multi-tenancy. So multi-tenancy is like tenant database, system database. We have applications, and this application is directly connecting with the tenant database. So we have in databases also we'll have main database, and then we have tenant databases. Okay, so tenant databases are something which will be directly acting as a individual standalone database. Individual standalone database. It will act like an individual standalone database. So now here we are understanding the runtime and design time architectures. So runtime and design time architectures is, for example, we have a calculation view. What is a calculation view? I'll explain you. That will be coming in the HANA Studio. But we have design time, we have package, and we have in the package we have some values. So we have fixed target database schema, that is SysBig, any database schema and any database schema. So these are the SysBig. SysBig is a standard schema that we have. I'll be explaining about what is a schema and all. Then I'll be explaining about this one. So we have a flexible architecture here, wherein you can do the development either in the ABAP mode or be using this calculation views, table definitions, function definitions, table synonyms, and all these things. We have Java module. In Java also we can do the development, and HTML also we can do the development, and then we can show that in the runtime. So here we are describing the high availability. High availability in the sense like if let's say we have some access of data, data backup. Data backup is done in multiple servers. So we have data area and log area. So we have commit here, save point. So when there is a loss of power and then again the back power is back, immediately it will again update the data in the remote. I mean like in the RAM. In the RAM, it will upload the data. Once you reboot the server also, it will again upload the data into the RAM. Remember, RAM, once you shut down the system, RAM, everything will be washed out. No data will be stored in the RAM. Okay, once you shut down. Once you reboot it, quickly the data will again be reloaded into the in memory. So high availability in the server down. So when the server is down, let's say now there will be like node 1, node 2, node 3, node 4. In that way, each node acts like a database. Okay. And let's say if one node is down, one node has become down, then immediately the standalone node will be getting activated. So if the standalone node will be taking care of the load of that particular node. So if let's say node 1 failed, then that node will be, that node load will be taken by the standalone node. So here we are describing the security features of HANA. So here we have authentication, SSO, authorizations, user roles, encryption, audit login. These are all the things that we have. So let's discuss from one by one. Okay, security features. We have authentication, the authorizations, user roles, encryption, auditing logging. So I'll be explaining about these things. So these are the various options to secure the data. So when we are logging in from the browser, we'll be first asked for the admin development and application, admin development or application, whether it is admin or the application development. So once it's been done, we'll go for the access engine. Through access engine, we'll be connecting to the system. We have this design time memory. If you're logging in from the HANA tools, then we'll directly log into the database. And if it's application server client, that's via username and password, then also we are connecting to the database. Only when we are logging from browser, we are using the access engine. Access engine enables us to connect from the web login and various other systems also. We can log in into the SAP system through the access engine or access advanced engine. So managing security with the pocket. So here we have this. In this we'll have the security here. Okay. So this is about small this thing. So in that administration part and the security part is something which needs to be understood more in depth by the networking people. But from the ABAP concept point of view, the most important things that we have to discuss or we need to understand very thoroughly is the row storage and column storage, compression of data, and parallel processing. These are the two. These are the things that we have to be uh, understanding very clearly. See, the most important thing that we need to understand is the in-memory database. Second one is row storage versus column storage. Then we have discussed about the compression of data. So compression of data is related to the columnar storage. Compression of data. Then we discussed about the parallel processing. So these are very important from the ABAP perspective, because when we are doing the coding, we should be able to understand these things.